Myself, K. Ganesh. Nichols prism. I'm going to explain Nichols prism. Nichols prism is a device for producing and analyzing a plane polarized light. When an ordinary light is transmitted through a calcite crystal, it splits into ordinary and extraordinary beams, which are completely plane polarized with vibrations in two mutually perpendicular planes. Nichols prism is a device for producing and analyzing a plane polarized light. The construction for Nichols prism: a calcite crystal whose length is 3 times its width is taken. The end faces of this crystal are grounded in such a way that the angles in the prism section become 68 degrees and 112 degrees also, instead of 71 degrees and 110 degrees. This is done to increase the field of view. The crystal is cut into two pieces by a plane perpendicular to the principal section, as well as the end faces PR and QS. The two cut surfaces are grounded and polished optically flat and then cemented together by Canada Plasm. The crystal is cut into two pieces. So the crystal is cut into two pieces by a plane perpendicular to the principal section as well as the end faces PQ and RS. PQ and RS. The, the two the refractive index of Canada plasm lies between the refractive index for the ordinary and extraordinary rays for calcite. Canada plasm is a transparent material which is optically more dense than calcite or ore and less dense for E ray. Hence, ore can be totally internally reflected by the cement if it is incident at the proper angle. The extraordinary ray is not totally reflected because it is traveling from a denser to a rarer medium and is thus transmitted with no appreciable loss in intensity. It is slightly displaced laterally and emerges out of the prism and parallel to its original direction. Thus, only the extraordinary ray is transmitted, since extraordinary ray is plane polarized, having vibrations parallel to principal plane. The light emerging from the Nichols prism is plane polarized. So here Canada plasm is a transparent material which is optically more dense than calcite for Ore and less dense for Erie. The extraordinary ray is not totally reflected because it is traveling from a denser to a rarer medium and is thus transmitted with no appreciable loss in intensity. It is slightly displaced laterally and emerges out of the prism parallel to its original direction. So a Nichols prism construction is up to the mark. When two Nichols are arranged coaxially, then the first Nichols which produce plane polarized light is known as polarizer, which he produce which analyzes the polarized light is known as analyzer. So Nichols prism can be used as polarizer and analyzer. When the two Nichols are placed with their principal sections parallel to each other, then the extraordinary ray transmitted by one is freely transmitted by the other. If the second prism is gradually rotated, then the intensity of extraordinary ray gradually decreases, and when the two Nichols are at right angle to each other, that is, they are in the crossed position, no light comes from the second prism. So there is no light from the second prism. This is due to the fact that when the polarized extraordinary ray enters the second Nichols prism, it acts as the ordinary ray and is totally refracted. Then the first Nichols prism N1 produces plane which is parallel to light, and the second Nichols prism N2 detects it. So the Nichols prism is completed. Thank you.